All right, let's get started. Okay, so today we're going to look at solving quadratics again using a different method this time.
How many methods are there? Like, why do we have to keep?
Whoa, just relax. Just relax.
Hold on.
These different methods are not there to cause you strife. They're there to give you options of different ways to go about solving these things so that you can have some different... Anyway, all right. So, question, yes? Strife, bad things that are happening to you that cause pain, stress. Okay, so completing the square is another method for solving quadratics. Now, sometimes with the other methods, there were certain ways that we would see the quadratics where one method might work or not. Completing the square will pretty much work every time as long as you can get it into standard form to begin with and then take it from there. Okay? But before we can talk about the method completing the square to solve quadratics, we need to talk about what a perfect square is. Okay? And we're going to start with something that you guys already have a pretty decent understanding of. And that would be just perfect square numbers. So I would like you guys, by raising your hands, and I will call on you, to give me some numbers that you know are perfect squares. Yeah. 16 is a perfect square. Anybody else? Perfect square? Yeah. 2 is not a perfect square, actually. Yeah. 81 is a perfect square. Anybody else? Yeah. 25. Let's take 2 more. Oh, you've already answered one. Jason? 100. And then one other person. Yeah. 9? Yeah. Okay. So, how do you know that those are perfect squares? What makes them perfect squares?
No decimals.
Somebody raise your hand. Yeah?
There are no decimals.
There are no decimals. Well, there's lots of other numbers that are no decimals. You mean when you take a square root, there are no decimals?
Yeah.
Uh-huh. Well, why is that? How does that come about? Why is, like, the square root of 16 4? What does that mean? Yeah.
4 times 4.
Okay. So they're numbers where there's some other number that you multiply with itself to get that one. And you can write them as, well, squares. So 16 is 4 squared. And 81 is 9 squared, etc. Any number that you can write as another number squared, we call a perfect square. So there are perfect square numbers. There are also perfect square quadratics. I'll give you an example of a perfect square quadratic. X squared plus 6x plus 9. That's a perfect square quadratic because that's equal to x plus 3 squared. I can take this and write it as something else squared. Just like I can take 16, write it as 4 squared. I can take this quadratic, write it as x plus 3 squared. Okay? It's that same idea. All right? So, how do I know just by looking when I have a quadratic that's a perfect square or not? So that's what we're going to investigate here to start off with. Okay? So, we're going to look for some patterns, and we'll do this one first. But we're going to write down a whole bunch of other perfect square quadratics and take a look and see, like I said, look for some patterns in there. So, x plus 3 squared, the reason that I knew it was this is because I did a little multiplying in my head. If it's x plus 3 squared, that's x plus 3 times x plus 3, right? Whatever's being squared, it's that thing times itself. So x plus 3 times x plus 3. Hey, I got to FOIL that thing out, right? X times x gives you x squared. X times 3, 3x. 3 times x, another 3x. And 3 times 3 is 9. And you can bind up the like terms in the middle. X squared plus 6x plus 9. Kind of. And there, like I said, there's some patterns in there that like these two numbers, the 6 and the 9, they relate to that 3. And don't try to make some guesses just yet, because it might not be right. But let's do some more, and so we can be sure of it. So I'm going to give you some more that I want you to multiply out, just like you did this one, and then we're going to write those perfect square quadratics up in our list, and then take a look and see if we can figure out what's going on. Okay. So let's do x minus 2 squared, x plus 5 squared, and x minus 7 squared. So take a few minutes. Multiply those out just like we did the x plus 3. Okay, and let's see what we get. All right, if you're not quite done, don't look up just yet. But if you are, that's what you should have. So you can check them out, see how you did. All right, and then those 3, we're going to put them up here into our list. And like I said, kind of see if we notice any little patterns emerging with those. So x squared minus 4x plus 4, that was x minus 2 squared. And x squared plus 10x plus 25, that was x plus 5 squared. And x squared minus 14x plus 49, that was x minus 7 squared. Okay, so raise of hands. Anybody see some patterns in there? Claypool, what do you got?
Whatever B is, it's that number divided by 2. And then C is that number squared.
Square root of that number, you mean?
Square root of that number.
Yeah, okay. So this number in the middle is always twice whatever this number was over here. And the number on the end, your C, is always this number on the end of these squared. Okay? This number? Yes. Yeah. So that's one key. If you're looking at a quadratic and you're trying to determine if it's a perfect square or not, that's one thing that definitely has to be true. This has to be plus. And also, these numbers on the end would have to be one of these, right? A perfect square number has to show up at the end of the quadratic as well. Okay? So that's how we can identify if they're perfect squares. What we really want to do, though, is to create a perfect square quadratic. So we might have like a partial quadratic. Like we have just, let's say, like maybe the first 2 terms, and we need to figure out what number do we add on to it to make it a perfect square. Okay? And I'm going to show you later why we want them to be perfect squares and how that's helpful. But that's kind of our first goal here, is to figure out what we need to add on to a quadratic to make it a perfect square then. Yeah? Correct. That's what we're going to do. Yep. So let's see. You'd have something like this. So what value of c makes f of x a perfect square? We'll take a look at two of these. All right, so I think Nathan already hit the nail on the head here with this. He said, you just got to take whatever that second number is, divide it by 2, and then multiply it by itself. Okay, take a look up here at the ones that we already wrote down. Follow that logic for a second. What's half of 6?
3.
Which is this number, right? This number squared?
9.
That number. Half of negative 4?
2.
Negative 2.
Oh,
Square it.
4.
4. Half of 10?
5.
Squared?
5.
25. Half of negative 14? Negative 7. Squared? 49. So they all have that kind of pattern going on, right? So half the middle term squared will always give you the last one. Okay? So for this one right here then, if we follow that same kind of pattern, what's going to be the c? 16, right? Half of negative 8 is negative 4. Negative 4 squared is 16. Now this one, you probably would need a calculator for, right? 12.25 is right, yeah. So half of 7, 3.5. 3.5 squared is 12.25. It still would be. Oh, is the 12.25 a perfect square number? Okay, so when I was up here talking about, all right, so these numbers need to be perfect squares or whatever, that's as long as the number in the middle is even, because then you can divide it by 2 evenly into a whole number and then square it. If the number in the middle is odd, like a 7, then that actually isn't true. But it still can be a perfect square, though, otherwise. Okay, so that process, though, that's important. We're going to be using that a bunch, okay? Taking the middle term, dividing it by 2, squaring it, that's what we need, okay? Because that's a means for us to solve some quadratics. So let's actually put that into practice here for a second. So like I said earlier, the thing needs to be in standard form to start with. So let's say we've got x squared minus 10x plus 7 equals 0. And we want to solve that. Well, if we're going to use this whole completing the square idea, we need to get that 7 out of there. Because right now that plus 7 is not making this thing a perfect square. Okay? What number should be there instead of 7 to make this thing a perfect square? 25, right? Half of negative 10 is negative 5. Negative 5 squared should be a 25. So, here's what we're going to do. We're just going to move the 7 out of the way. Put it to the other side of the equation instead. Then we can put our 25 in there. But Mr. Herrick, this is algebra, and whenever we're solving equations in algebra, we have to do the same thing to both sides, right? Right. That's what makes it a perfect square. Like we were doing earlier. What's half of negative 10? And then square it, get 25, right? So, yeah, I completed my square on the one side, hooray. But whatever I used to complete the square on that side, I got to add the same number on the other side to make sure things are still balanced. This is an equation, right? It's got to stay balanced. Okay? So, now, this x squared minus 10x plus 25, I can write it like a perfect square. What is that squared?
X minus 5 squared.
You got it. It's x minus 5 squared. Okay.
Equals what? 20? No, not. Equals 18. 18. Is that our answer now?
No, all we've done now is we've taken this original quadratic and we've rewritten it in a way where we can use an old method that worked pretty well for us. And that was the whole square rooting both sides of the equation thing. It took really specific looking kinds of quadratics for that square root technique to work last week. Okay? If you can complete the square, you can get any quadratic to look that way. And then go ahead and square root both sides. Yeah, absolutely.
Now we got a square root 18.
Mm-hmm. Not 18 squared, but the square root of 18.
That's what I meant.
Because if we square root this side, that's going to cancel the square and leave just x minus 5. But then we also need to square root over here. So what we're going to have here is x minus 5 equals,
4.20.
except we're going to keep things exact, so no rounded off decimals, plus or minus the square root of 18.
So how do we answer this?
Well, you want to know what's the value of x, right?
Yeah, because we cannot simplify that anymore, right?
Technically you could.
How?
Well, are you talking about the square root of 18? Or the fact that there's still a minus 5 next to the x?
Well, you can't possibly solve for x, right?
Yeah, you can.
How?
Add 5 to the other side.
Oh. So plus 5?
If you want to do it that way, I'm going to write it like this, though, because this is kind of the more accepted way of writing it with a plus or minus. But you could do plus or minus square root 18 plus 5 after it. That's still fine. It's the same thing. So I'd be kind of looking for this, personally. But there are lots of different ways to write that and have it be the same thing. So 5 plus or minus the square root of 18.
So it can't be the square root of 23?
No, because those aren't like terms.
Right.
One's a square root, one's not, so you can't combine them together. So you got to leave them separate like that. Another thing that I probably should mention about this, though, is your textbook is probably going to write it like this. Okay, but now, I'm not saying that you have to do that, but if you're looking up answers in the back of the book, just so you know, what did they do there? How did they get 3 square root of 2? Yeah, what's 18? Yeah, except when you say squared, you mean square root, right? Yeah. Okay, so square root of 9, square root of 2, square root of 9 is 3, so it's 3 square root 2. Okay, but, yeah, well, good. Anyway, so that's what you're going to see in the back of the textbook if you're checking things out. But, you know, I think if you have this written down and you see this, I think you guys are smart enough to recognize that that's the same thing, though, okay? But just so you know. Okay. So let's try a few more of these just to make sure we're good with this whole process here.
Is this what we're doing?
This type of thing, yeah, pretty much.
We gotta write quadratic. I'll be done with this one. I'll be done before classes.
Okay. So you might come across something that looks like this. X squared minus plus 16, x plus 64 equals 144. Now in the past, what would you do?
You would take 64 and subtract to 144.
Okay, so if you wanted to complete the square, you take that 64, move it over to the other side, subtract it from 144. But what's half of 16? What's 8 squared?
64.
It's already been done. The square is already complete. So you don't need to move that 64 in this one necessarily. You could, but you just end up adding it right back on again. Okay? So if you notice that the quadratic that they start you with is already a perfect square, just stop and go to the next step then. Okay?
X plus 8 squared.
Well, we're not quite ready to do the square root of both sides, but yeah, we got to write it in the parentheses with the square first. make it that perfect square look. So what would this be squared then?
X plus 8.
Yeah, everybody catch that? X plus 8 squared equals 144. Hold on just a second. All right. Now we're ready to square root both sides. Okay. And the other nice thing about this example, when we go to do that,
That's cool. X equals 4.
what's the square root of 144?
12.
12. Okay. However, be careful though. It's x plus 8 equals plus or minus the square root of 144. So plus or minus 12, technically.
X would equal plus or minus 4.
Just hold on. Now, if you can't do this in your head, I would recommend just writing it as two separate little problems. Okay? I know we have some people that every time they write an extra line for a problem that they're doing in math class, a little piece of them dies. But it's not that bad. Okay? I'm sure you'll get over it. X plus 8 equals 12. And then it's also x plus 8 equals negative 12. Okay? Take an extra line of paper and make sure you got it right. So, what are the two values of x for this particular problem? This should be 4, right?
X equals 4 and X equals negative 4.
Try again. Negative 20. Yeah. Subtract 8 from each side, it's negative 20. So the two solutions here are 4 and negative 20. So if you can actually take the square root, you should have two numbers when you're done, right? One from the plus, one from the minus. And they might not be the same number. It's not always just plus or minus some number. They could be completely different like that because of how it's set up. Yeah? Where did 64 go? This right here I knew was a perfect square that I could write as x plus 8 squared. So if I were to actually like FOIL this thing out, x plus 8 times x plus 8, I would get this. So it got absorbed into this when I turned it into that square. So, yeah, Zach? Then it looks like the one we just did before. The example before that where we had to leave the square root in the answer. Okay, sometimes they're like that. Sometimes they're like this, where it actually goes away. It just kind of depends on the number that you have to work with there, though. Okay. All right, let's try another one. And do a couple few more of these. Make sure we're good. X squared plus 14x minus 3. Yeah.
I think I have to go to a meeting.
What's the time on the slip?
1:25.
1:25? You missed it. You'll have to wait for her to get you another slip. Okay, so this one I want you guys so we're not all shouting things out, but raise your hands. Tell me what I should do next and give me the process here. So somebody raise their hand and tell me what I should do first on this one. Emily? Add 3. Okay. So tell me, Emily, the last example that we just did, I didn't add or subtract anything to the other side, so why am I doing it now? Okay, and is x squared plus 14x minus 3 a perfect square? No. So I'm not starting with a perfect square, so I don't want to just leave it there. I got to move it out of the way. Okay, correct. So somebody else raise their hand. What's next then? Yeah. Add 49 to each side. Good. That's going to complete the square. And then I got to keep things balanced, so put the 49 on the other side. Okay. Somebody else then. What now? I got my perfect square. But what would be the natural next step then after that? Let's have somebody different this time. Gonna mix it up a little bit. Mm-hmm. So x plus 7 squared, right? Because half of 14 is 7, equals 3 plus 49, which would be 52. Okay, so somebody else has not spoken yet. What's next? You have spoken already. Yes, you have. Somebody else. Jason. Square root, right? Okay, and don't forget the little plus or minus here. So x plus 7 equals plus or minus square root of 52. Almost there. What's left? Somebody else who has not spoken yet. Subtract 7. Mm-hmm.
Holy crap, I forgot to write 2.
Negative 7 plus or minus the square root of 52. All right. This one, square root of 52, I think can be reduced. So your textbook would probably have something that looks like this. I didn't say decimal. 52, 4 goes into 52 13 times.
26 and then 2.
4 times 13 is 52, right? Square root of 4 is 2, so 2 comes out. 2 square root 13. So they'd have it like this. But this is good. Okay. One more example like this, and then I have a vertex form thing I want to talk about, and then I'm done. So 2 more, essentially, here. This one's got a couple other things going on, but I bet you guys can handle it. So what if the first term is not just x squared? What if it's 3x squared? Exactly. If it doesn't look the way you want it to, that you're used to seeing it, change it. Okay? So we're used to having it just be x squared up front. So if it's being multiplied by a 3, divide by 3 and then it's gone. Okay? But again, we're working with an equation, so if I divide one thing by 3, I got to divide everything by 3. And it's not just both sides, it's everything on both sides, so all of that. It's like putting a giant division bar underneath it in 3. Okay? Claypool question.
Since you have to already add 15 to the other side, can you just make the other side 5?
Sure. Yeah, you can do that.
That you could.
Yep, that's fine. If you want to divide by 3 after you move the 15, that's okay.
Does that change the equation too?
No.
But instead of it being 144.
You're not multiplying by 3.
Yeah, I know, but.
Oh, no. You would have to divide by 3 before you complete the square, though. But you can divide by 3 after you move the 15. That's okay.
Because it's going to be plus 9.
Yeah, you can't actually complete the square unless it has just x squared up front. Okay? So if you were trying to take the 12 and divide it by 2 and then square it and all that, it's going to be wrong because it doesn't start with a correct number in front. But after we divide by 3, 4x, 5, okay, now it's just like all the rest, okay? But this one, as you solve it, you're going to see there's something different about it. Okay, if you've worked ahead a little bit, maybe you already see it. So I'm going to move the 5 over. What's going to complete the square? 4. Okay. So x squared plus 4x plus 4, negative 5 plus 4. So this thing as a perfect square then is x plus 2 equals negative 1. How to get the what? Because that's what completed the square. Half of, look at the 4x. Half of 4 is 2. 2 squared is 4. So it's always half that number squared. So that's how I got the 4 there for each of them. It's not. Not based after, not after what we talked about on Friday. Okay? Square root of negative 1 is what? It's I. So we're going to have I as a solution coming up here. Well, it's going to have I in the answer anyway. So square root both sides of that thing. So the left-hand side, still the same thing. It's just going to be x plus 2. The other side, though, and don't forget plus or minus, right? So it's plus or minus I.
No, don't we have to put equals 2 plus minus I?
Well, it'd be negative 2. It'd be negative 2 plus or minus I. You multiply it instead of adding them together. So there are 2 complex numbers that are solutions of this quadratic. Do you see them?
Yeah.
Negative 2 plus I is one complex number, and negative 2 minus I is the other complex number. Okay? You might come across some of these in your homework. Okay? When you do that square root step to each side, if it happens to be a negative number on the other side, that's okay. Just keep going with it. You're just going to have to make an I in there somewhere when you do it. Okay? So that's why I wanted to show you that one too, is to show you that, yeah, that still does happen. Okay. Then, very last thing. I debated showing this to you, but decided I would. This is another example of this might be an easier way to do something that I've already had you do, and maybe you would like to do it this way instead. So I'm going to show it to you. Okay? If you have some kind of quadratic that is in standard form and you want to put it into vertex form instead, okay, completing the square can actually make it a little bit easier. So let's say I'm starting with this. X squared minus 12x plus 18. And remember, vertex form looks like this. We had a few of us on our tests that got that confused with some other stuff. So I want to be sure that we're clear on that. That's vertex form. And the H and the K are the vertex. A vertex has an X coordinate and a Y coordinate. And that's where they would go in there. The old method that we had for writing something in vertex form was that whole negative b over 2a stuff. You'd take a look at your quadratic, find the a, the b, and the c. You'd do negative b divided by 2 times a. That's the x coordinate of the vertex. Then what do you do with that number? Plug it back into the equation, work it out. Then you get the y coordinate, and then boom, boom, there's your vertex, which is essentially the h and the k, and then you can just dump them back in, and you have your vertex form then. Okay? So, if you like that, there's no problem with that. You could write something in vertex form doing that. Otherwise, we can take this thing and complete it square. Because 18 right now is not completing this square. What number should be there instead of 18 to complete the square? 36. So, I got to get this 18 out of there. So I'm going to move it over with the y to kind of just get it out of my way. And then we can take that x squared minus 12x, complete the square. So I got to add 36, but I got to add it to both sides, right? So I got to put this plus 36 over here too then. Okay, so what's negative 18 plus 36? 18. Yeah, it's positive 18. And then, what do I have over here as my perfect square then? X minus 6. Okay. And then, to put it in vertex form, I just got to then shuffle this 18 back over to the other side at the end. So it'd be y equals x minus 6 squared minus 18. I got to subtract it back over, right? Okay. So there's your vertex form. So if you like completing the square, it's an easy way to get to vertex form. If you'd rather try to remember that formula and follow that and do that instead, nothing wrong with it. That works too. But I just thought it was worth showing you guys that it's a pretty easy way to convert it doing this stuff if you want. And I believe in your homework they actually have you doing some of this too. They have you changing some things into vertex form. So, okay, that's all I got. I'll let you guys get going on some homework here.